wasn't long ago I came to this town, drunk on hope, looking for opportunity. But when Lady Opportunity wouldn't show me her pretty face, I didn't know where. So I took this job. I tracked down this man they call Sicilian. And you see, everyone in this town knew the Sicilian. You know, we didn't know his face or where he lived, but we knew him. Because if you wanted something, the Sicilian had it. It had its price. The Sicilian had his boys in every nook and cranny of this town. But when I tried to ask for him, look around for leads, find evidence, it all came out dry. Every time I got closer, it came out cleaner than ever. And that's what brought me here, to this filthy alley on a cold fall evening. It was to be my first job, the development. I found love. Yo, yo, yo. Hopefully y'all can hear the audio. Well, I assume you guys can hear the audio. So today we'll be going through some different things than last time. We'll be going through a bit more of a setup kind of process. We won't be doing the visual thing right away this tutorial, but we'll be doing that later. For now, we're going to kind of set up for doing that in the future. So let's get to it. Again, we will be cloning some code from GitHub, like we did last time, the link for which I will provide to you guys in the chat right now. Yes, all right. Oh, and Zoom is crashing. Off to a great start. Ah. Huh, okay. Well, I'm not sure if you guys can actually hear me. If you can, please let me know, but my Zoom seems to not be responding. Hello all. Is this working? Alright, can you guys hear me now? Oh, all right, so when did it cut off? All right, looks like my Zoom just crashed there. Around when did it cut off? Okay, sweet, so it still kind of worked. All right, again, we're gonna be, like last time, we'll be copying a project from GitHub, but this time it won't be like the same. We won't be using the visualizer right now, but that's what we're cloning, and I can show you guys again really quickly how we do that. In Eclipse or IntelliJ. We'll start off today with IntelliJ because it's easier, and then I'll show you guys how to clone in Eclipse. That's what we did last time as well, just to review in case some of you guys were not there. And we'll switch over to the screen where we can actually see Eclipse and IntelliJ. All right. Oh. VCS, get from version control. Paste in your link, which I sent to the chat. Close that. All this stuff can go away, this window. And that's all you have to do in IntelliJ. You just click VCS, get from version control, paste the link I sent to the chat, and you should be able to see our project. Now, similarly, in Eclipse, you'll go into, oh, minimize the wrong window there. Into Eclipse, and we'll do the same thing, just like last tutorial. If any of you guys have trouble. Oh, yeah, I'll send the link once again. So yeah, same as last time in Eclipse, this time around, we'll be doing the same process, just cloning the GitHub repository. And the point of today's tutorial is to talk about access modifiers like private and public, the reason we have getters and setters to protect our different variables and fields from manipulation externally, and other related object-oriented programming topics. So we import from Git with smart import, just like last time, clone URI, paste in our URL that I sent to the chat, and go through it like that. Alright, and then you should have a Comp 250 tutorial week 2. If any of you guys have trouble with that, let me know. I'll give you guys a little bit of time to finish up. In fact, I'll just start a poll asking if you are done. And then once enough people say they are done, we will be good to go to the next thing. Are you done? Yes. No. Alright, we've got our poll as to whether or not you are done, and I will set it up once you guys are. And yes, for now, I shall show you once again what I did in Eclipse. I just go to File, Import. Here there's a bunch of folders. You change the Git folder, Smart Import, clone URI, paste in the link, and just hit Next a bunch of times. So yes, now I just wait up until you guys set it up. That's, if you guys want to see the Eclipse thing once again, I can show you once again, or if that is sufficient, that is sufficient. Again, it is File, Import, Projects from Git with Smart Import. That's under the Git folder. Paste in your link. Well, clone URI, then paste in your link. Then Next, then it should all go. For me, it won't go because I already did it, but for you, you would not have already done it, so it would just allow you to click Finish, and then you'll have the folder appear here. Alright. And yeah, again, for IntelliJ, that's just VCS Git. Or not VCS Git. VCS get from version control and paste the link. Alright. If any of you guys are having trouble, I can see about helping you out, and do feel free to just randomly interrupt it. After you paste the link, you just keep hitting Next and clicking like just whatever the option for Next or Finish is until it finishes. There's a bunch of options, but you don't have to use any of them. Now, which file do we have to open in the source folder? Well, I'll get to that once most people have cloned it. There's a lot of files here, you'll notice. Like, there's just an absolute ton of them. And that's because we'll be working from this project for a little bit when we start going into inheritance and all that stuff like that. But for now, we're just going to be opening attackthecartel.java, and I'll explain things from there. I'm just going to wait up for everybody to be able to see it on their screens, though. Just got to get everybody cloned, and we'll be good to go. Alright, well, the majority of people have, or I guess the plurality of people have voted yes on the poll, and as such, I will assume that, oh yeah, I can show you again. I'll assume that most people have done it, so I can start going into it soon. I'll just show for the stragglers the process once again. It's import projects from Git with smart import. Next, clone URI, paste the link. Next, just don't click anything and click next. And then just click Finish. It won't let me click Finish because I already did it, but if you didn't already do it, it will let you click Finish, and then you'll have the project show up over here. And yeah. Alright, so since the plurality of people have done it, I'll start getting into the actual coding part of it. So we'll open attackthecartel.java, and you'll see here that we've got a lot of different classes. We've got a cartel class, a client class. Now, our goal today is to make the cartel class not suck. See, the problem with the cartel class is we can really easily screw it over. Like, we can really easily attack it. Here we see we are represented by the user here. Cartel is represented by cartel C. And if we go through, we can just set our money to whatever we want, which is okay because that's part of the program. But what isn't okay is we can just set the cartel's money directly to be 0 and just take away all their money. We can send police in to raid them. We can sell products to whoever we want, which is not ideal. We can just take their merchandise, set it to null. We can just erase their blacklist, delete their supplier. Not a very good situation for the cartel here, as you can see. And we're going to work with cartel.java to fix that. So you can see here, we've got our fields that we're playing with over here. Well, what all these fancy things are, it doesn't really matter to us right now. Like, what is an array list, what is a concurrent link to Deke, it does not matter for the scope of this tutorial. And a product factory is the thing I made. It doesn't. None of this matters. What matters is the fact that some of these things have private and some of them don't. And again, the point of this one is to explain private, public, get, and set, basically. And once everybody is ready to go, we can start getting into that. If everybody is, just let me know in the chat that you are good to start off, and we will do so. All right, does everybody share? All right, perfect. So if we try to run attack the cartel, it doesn't print anything, right? But it also doesn't throw any errors. And let's say if at the end of the day we tried to see like system.out.println. Let's see, well, I don't even have getters or setters yet, so just c.money or something. Like, right, we can see that by the end of what we ran, we basically screwed them over and zeroed them out. What we have to code? Well, what we have to code we'll be coming to. We'll not actually write new code. We'll be fixing code that I wrote that was bad. I'm just explaining here that when we have access to the fields of a class directly, we can really screw it over. Like when we can directly just from our class modify all the fields of this cartel, basically reduce them to nothing because they have everything in their package without access modifiers. So what we're going to do is we're going to go into cartel.java and we're going to fix it. But before we can do this, we got to explain exactly what these access modifiers do. So if we create a new class, and you guys can follow along with this, or you can just watch. Either way, it will work. It will call the name like, I'll just say test class, right? And it's all public and normal, and everything is as it would be. And notice how we can put variables outside of a method. We call them fields. These variables have to do with this class. So I can just have an int random number. It's not random, but like, it's equals 0. Right? And there's a main, like a public static void main string args, and whatever. There's like a normal looking class. This is the kind of stuff you've all seen before, right? Well, have you guys thought about what the access modifiers before this could mean? Like, why do we put private here sometimes, and other times you might see protected, or you might see public. You might see all these different modifiers before your fields, and same thing exists with methods. So when you're writing a method, you can say like public int get random number, return random number. And you might think, what the heck is the point of having a method which just takes this field here that you have access to anyway and just returns it directly without doing anything? And that's a whole idea in object-oriented programming called encapsulation. I don't know if you guys have heard of encapsulation or not. They might have used that term to refer to it in the lectures. They might not have. But the point of encapsulation is that in programming, you basically want to make sure that people cannot screw up if they wanted to. Like you prevent people from misusing your program as much as possible. And in order to prevent people from misusing your program, you can change the access modifiers. But they don't actually do anything when you're inside this class. Like inside of test class, private and public literally are meaningless. They only start mattering once you start accessing this class from outside. And that's why I've got this big complicated list of classes here. For now, the only ones we care about are going to be cartel and attack the cartel. All the other ones are for later tutorials. But in terms of cartel.java, you can see here that some of our things are private, some of our things are not private. Now, what we can do with this is we can kind of demonstrate how we can attack these things from outside. Now here, we've got a cartel called C, right? And if I try to do c.name, it's just not there. It doesn't exist. If I go into cartel.java, you can see that c.name is here. There's a property called name. but, well, actually, where did it go? There's a property called name. It's right here. But for some reason, we can't see it in attack the cartel from here. We can see fields which have no modifier. Like we can see merchandise, c.merchandise. That is just a thing that exists. But we can't see c.name. So could you guys potentially think of a decent way to prevent me from just zeroing out the merchandise from this class? Any ideas of what I could do to this merchandise field to make me no longer be able to access it from this other class? If you guys have any ideas for that, yeah, you make it private. Exactly. It's a pretty simple example of why you would want a private field. Hopefully you guys are along with this whole nonsensical noir film analogy thing going on. But essentially what we're saying is there are certain things in your classes, for example, let's say the merchandise of a cartel, which you don't want just about anybody accessing and modifying, right? There's also examples of this outside of this cartel analogy. For example, if you're working with a data structure, you may not want people to be able to access certain intrinsic properties of it, like a cursor that you use to iterate and stuff like that. Like there's lots of different times where it would be really, really bad if somebody accessed a field. Like there are times when a field should only be modified from within its own class. For instance, the merchandise of a cartel. If you're running a cartel, you probably don't want anybody to have free access to your merchandise. Similarly, in other situations, which you'll see throughout this course, there will be times when there are fields which you do not want anyone to have access to. And that is why, yes, we can modify this to just say, right here, private. And then we can do the same thing with all the other stuff. See, like the blacklist can be private, and the product factory can be private. And now, when we try to run attack the cartel.java, you're going to see it's just going to screw up. It's not going to run. It's going to throw a bunch of exceptions, a bunch of errors, and that's a good thing. We want these to be errors because we don't want to be able to modify these things like this. But the tutorial doesn't finish there with this kind of stuff. It's actually a bit more complicated. So there are sometimes things which you want to modify or you want to access, but you want to have certain conditions when you access them. For instance, if you're running a cartel, you probably don't want to sell your merchandise to a police officer, right? Well, how are you going to be able to tell whether or not something is, whether who's accessing something or whether or not it's appropriate for something to be accessed? Well, that's why we have getters and setters. So if we go into cartel.java right now, this is cartel.java, we don't actually have getters and setters for stuff. So there's actually no way for us to access things like the supplier or the blacklist or the merchandise. There's just no way to get to it. And for that reason, we can make methods which get them. So right now, I've got a method which is a getter or a setter, and it's called sell product. Now it takes a buyer as input because it checks who it's selling to, and then it tries to run logic to sell the item that it's selling. So if we go in here, we can see there was like a lot of code. This is not relevant to what it does. It's just an example of code which will consider the buyer. It'll run a code to check whether the buyer is legit or not. It'll be like, when a method is accessed to private, yes. Private methods are a bit different than fields. Private methods are methods that are usually used as helpers. Not always, but kind of as a rule of thumb. If you have a method that's private, it's because it serves no purpose outside of the class. So it could be some algorithm thing you're doing. Like if you're doing some sorting, you probably want to have a public method called sort. And then if you're doing like merge sort or some other sorting algorithm that you'll see later in the class, you'll have private helper methods. Methods are, how are they different from fields? Well, methods are actually some bits of code. A method could be thought of as like shorthand for writing a bunch of code. So if you were to say have a task you need to complete reasonably often, for example here, there's a task to check the buyer and see if they're legit. You don't want to copy paste all the code that could potentially be in here. Right now it's just a comment because we're going to write this in a future tutorial, but imagine there was like a ton of code in here. And this is a task that you commonly want to do. You don't just want to check the buyer like only when you're selling to them. You probably want to check the buyer in other situations as well. So that's why you'd have this method written as a method. Instead of copy pasting all the code into here and putting it into your thing, you can just call it as check buyer. But technically, like a method could be thought of as shorthand for a bunch of code. A method is just a function. If you're familiar with the function terminology from other programming languages, that is what a method is. And there are situations like recursion and a bunch of other ones. I could name a ton, which have methods where you need to have it defined as a method. You can't just copy paste a little block of code, but that is not one of them. And a field is not like a method. A field is like a variable which only exists within the scope of a class. So maybe I should go into a bit of an explainer on object-oriented programming stuff before we get into this complicated stuff. This stuff is a bit maybe advanced for now. I don't know how much was learned before. So maybe I'll go into a bit of a quick explaining session on object-oriented programming. What do you guys say? Do you think that would be a better start to it? And sorry if my screen is a bit blurry, it's just my internet is not the best. So would you guys prefer if I keep trying to go with this private-public stuff, or do you want me to kind of go into some more rudimentary class stuff first? Oh, and sorry, the screen keeps flashing on my webcam. That's just a bad HDMI cable. But yeah, do you guys want me to go into some? Yeah, okay. Let's just do some rudimentary class stuff then, and we can get to this stuff perhaps on the next tutorial or later on in this one if you guys need it. Or I mean, when you guys need it for private-public stuff. So, what is a class? Well, there's a lot of like overplayed examples people give of classes throughout your time in comp sci. They will say things like, you can make a veterinary clinic and then you have a class for animals which defines every possible animal and stuff like that. So let's try with a class, and for now I'm going to do one of the simplest classes which I usually use as an example, which is the person class. So we'll just have a class called person, and the person class will encode certain properties of a person. Let's say that this is for our cartel managing program, and this is to encode the properties of any potential person who might be buying it. So let's think about how we can create this class. We've got a person class. Now, what is the important properties of a person? How about in the chat you guys name some important properties you probably care about if you are making a program that describes a person for the use of seeing whether or not they are an appropriate buyer for the merchandise of your cartel. Yeah, okay, so yeah, we can have a, let's call it a private Boolean gender. Yeah, okay, and we can have a private int friendliness. And you can have, a lot of these stuff. We have name, private string name. We don't need a ton of them. We can just do a few for now. Yeah, wealth, like lots of stuff. We'll just do a private long money because they can be very rich. But yeah, so that'll just stick with these four for now. So these are all properties of a person. And the reason I put these properties outside of a method in the fields is that a class can be thought of as kind of, a long is just a long integer. It's the same as typing int, except it has a larger maximum. The reason I put long for money is that usually when you put money in a computer, you would use each int as a cent, so you need a really, really long number a lot of the time. And no need to raise your hand there. I saw somebody did that. You can just interrupt me on the video. That's fine, if you guys are allowed. If you guys are not allowed to open the video, I'll have to change that. But like, if you want to raise your hand, just literally interrupt my thing, and you can go ahead and do that. Yeah, for sure. Okay, well, I'll get those questions, I'll divide it up into two questions. The reason that I am putting these things here is we're encoding the properties of a person into the fields of this class. And the reason that we're putting them here is that the field is kind of like this template, or the class is kind of like this template of what any person can be. If I were to give an example, it's like a form which has every different thing that could define a person listed out that you might want to see that's different between people. So every person has a name, but every person's name is different. And that's why it's going in the fields, and I'll explain that in a bit. As for the private versus public, that we'll go into when I can go into this code, because it's a little bit more complicated, and I prefer doing that with a hands-on example. I'm just putting private here for now, just out of instinct, because that's normally when you have fields like this, you want them to be private. And why that is, we can get into perhaps in the next tutorial or in this tutorial, depending on how quickly this all goes. So here we've got a person with these properties. They're the fields. And the reason they're fields is that every person has these things, but not every person has the same of these things. Let's say that there is something that every person has that is the same between everyone. For that, we can say it's a private static, let's say, string species. And then that can equal human. Now, we know that every person we're dealing with is a human. We could put, do we have to put private, public, or could we put nothing? We could put nothing. Nothing doesn't actually mean nothing. Nothing means package private, which means if you're in the same package, so here it's the Sicilian, it'll be visible, and if you're outside of the package, it's invisible. That's what no modifier does. It's package private. But for now, let's just not focus on it. In fact, for the sake of argument, I'm just going to not put any modifiers here. And we'll get to those when we get to those in the other part of this tutorial. So for now, we'll just put these like that, and we'll avoid the confusion of having private or public. So again, All of these things are properties of a human. Here, properties of a human, which every person has, but are different between people. And we'll put that comment just above the first thing. There we go. So these are properties of a human, which every person has, but are different between people. And these are properties of every human that are the same. Right? So notice the difference here. Properties which are different between people don't have static. Properties that are the same between all the people do have static. Now the reason for that is that if we have another class here, I'm going to call it class tester. Now in the class tester, if we have, let's say, person dot something, well, we can access, well, I guess new person. Yeah, what's wrong with that? Oh yeah, because I'm not in a method, sorry. Void main string args. So if we are in here, yes, you have to claim it. He just said no. I have no clue what that refers to, but okay. So here we can say person dot, and here we can see that the properties that are the same between all people you have access to, the static ones, without even declaring an object. You can just say person dot species, and that comes out. So you guys, and you cannot see things like friendliness. Now, why can't you access person dot friendliness, even though it's not private? There's seemingly no reason why you can't access person dot friendliness, but there is access for person dot species. The reason for that is it's static, and static means that no matter what the instance of an object is, it doesn't matter. You can still access it. And things that are not static vary by instance. Do you guys kind of get that? Like, is that now a bit clear to you guys that when something is static, it has to do with just the class? Any person has that field. And if something is not static, it depends on which specific one. All right, sweet. So now we can go into the specific ones. When we say person p equals new person, right? Now we can say p dot, and then we have all access to all these other fields, because now it's a specific person. But what happens if we actually want to put something into friendliness, name, gender, money, any of these things? Well, what we can do is we can say p dot gender is equal to true. I don't even know which gender true would be, but it is the true gender. P dot money will be equal to 999999999. So static objects aren't bound to a class object. That's one way to look at it. Yeah, it doesn't matter what exactly. Is that too long for a long, really? Okay. Yeah? Okay. Mafioso is the only true gender. Yeah, okay. So, p.money is whatever, right? We can do it like this. And you guys are getting that, right? Like, because this is a specific person, we can access the fields which are not static. But there's actually perhaps a better way, because if every time we create a person, we have to go here and we can put like p.name is equal to, you know, Frank or whatever. We have to do this for every single person. That's a lot of code. That's kind of annoying to write. And if we have to put this for every person, that's just annoying. So what we can do is we can make something called a constructor. We could say public person. And the way you put a constructor is you don't put a return type. You just put public and then the name of the class with this. And we can put in arguments. We could be like int friendliness, bool gender, string name, int money. And now you notice how these are the same as the fields. So what we can do is we can say this dot friendliness equals friendliness. This dot gender equals to gender. I don't know why it's not liking that. Let's see. Bruh. Did I spell that wrong? Yeah, I did. Okay. And I'll explain why we use this in a second. This dot name equals name, etc. So this is referring to this class. The reason I put this is that notice how here I have two things called gender. I've got gender and I've got this dot gender. So how do we know if gender refers to this Boolean gender or that Boolean gender? Well, do all four variables have to be in the constructor? No, you don't have to put all four variables in the constructor, and I'll get to that in a second. But for now, let's just say all four of them are there. So when we put this, that's what we use to differentiate between a local variable and a field. When we say this dot something, we're saying that we're setting this instance of a person's gender to gender, or we're sending this instance of a person's friendliness to friendliness. So now, if instead of putting these things over here, this is the same as self in Python. That's correct. If you're familiar with Python, this is the same thing as self. So here, we can just put in int for friendliness, let's say 10 friendliness, true gender, and a name of Frank, and money of 99999. Now you can see it's valid. So when we create this person, it now encodes this person with a friendliness of 10, a gender of true, a name of Frank, and, well, it doesn't actually do anything with the money because we don't actually do anything with the money here. But if we put this dot money equals money, that works. So hopefully that makes sense to you guys, right? Like there's putting a constructor with these arguments is the same as if I just put p dot money equals whatever, right? Do you guys kind of get that? Yeah? In the chat? Yeah, okay. So coming off of this, the reason that a method might also be advantageous is, let's say that it's not free to be created. You know, let's say we're in America and being born is going to cost you a pretty penny. So here we can say, when you get created, we're taking $150 right out of your bank account right away. And that way, when we create a person, their money will be set to that. And to show this to you guys, I can make a toString method. So it's called public string toString. And it's going to encode a person into a string, so we can actually play with this and watch it happen. So we can say, let's say, return friendliness equals friendliness. Notice how I don't have to type this dot here because it is there's no argument here. So friendliness is only defined as the field. Name equals name. Is name what I called it? Yeah. Money. Money. All right. So now if I just type out print line p and I run that. Yeah? What's going on here? What am I running? Am I not running the correct class? I should be running person. Oh, that's why. Can I not run class tester? Run as. Eh? Bruh. Oh, I think I have to configure it. Bloody Eclipse. Main class will be tester. Yeah. Okay, there we go. So yeah, we're initializing these variables, and you can see when I do this with the constructor, friendliness is set to 10, just like I had in this argument. Name is set to Frank, just like the argument, and the money is set to this thing I passed in minus the amount of money I taxed. Kind of makes sense to you guys, right? And again, I'd like to repeat that this is the same as if we set these fields. Well, it's kind of the same, except for the money tax thing. It's almost the same as if we had a blank constructor. Notice how I can have multiple constructors with different kinds of arguments. So you can have a constructor with no arguments, and I could just say person p equals new person. And if I try to print out this, or not person p, I'll just say p equals new person. And then I print line this person. It's going to throw some exceptions. Well, it's not going to throw exceptions. It's going to say it's null. So this is a person with everything being null. If we try to access the fields outside of the print line, like if we try to access these fields here, like p dot, what's not anything, like p dot name. If we try to like say dot char at 0, that's going to throw a null pointer exception because it's null. We never set it. Yeah, makes sense. And yeah, that's that. You guys can see that's how the constructors work. And then we can have multiple constructors. The toString is a method which is defined in every Java object, and every time you do system.println of an object, it actually calls toString. So I never called toString. The println called toString. If we're in IntelliJ, I can actually show you. I can dig into println and show you where it calls the toString method, which maybe I could do if I find println. And then you can actually see where it's called. Where do I have a println? I don't even think I have a single println in this code. Okay, well, I'll put a print line somewhere. Oh, attack the cartel. They should have a print line right here. Print line. Yeah. Okay. Now, if I go into here and I go, go to implementations. Oh, annoying. They have it be way more complicated than it has to be. But here we can see, oh, there's a string one separately. No, we need a print line object O. You can see they have different print line methods for every different kind of variable. We just want a print line for object. Here we go. So here it calls toString in this large batch of code. Where can we go? Oh, string value of, and string value of should call toString. So if I go to usages, yeah, right here. So we've dug in and we found where toString is called. toString is called in string.valueof, which is called by printline, which is called when we do system.println. So that might make it a bit clearer to you guys why toString methods exist. They will come up in Comp 250. Even in your first assignment, you'll have a toString method. And what happens is anytime you print any object, so printline with object x, it will call printline from right over here. And just another tip for you guys, if you ever want to examine how something works in Java, what you can do is you can go into a class, let's say the cartel class, and in IntelliJ you can go to like declarations or usages, and it shows you where the thing was declared. And you can really get a lot of understanding of how Java works through doing that. I don't believe there's an equivalent in Eclipse, so that's just a trick for you all IntelliJ users out there. But yeah, could be fun to do. It's sometimes fun to just like look around and see how Java does things. But yeah, that's where toString is called. And now you'll know when I call toString, that's just what it's putting out, or when I call printline, that's what it's going to print. So yeah, there's two ways to set the fields. But now, let's say we want to enforce some rules, right? What if somebody wants to set their name to be a swear word? Let's say there exists only one swear word, and we'll put it up here. It's going to be public static final, which are all final just means it never changes. Word or string swear word equals frick. Now, we could not have somebody named Frick. If we have somebody named Frick, that's just the end of the world. You know, it would be the most horrible thing. So how are we going to stop someone from being named Frick? Anybody got any ideas? As for the uppercase or lowercase, let's just say that the only version of Frick, which is a swear word, is where all the letters are uppercase. But like, how do we prevent somebody from being called Frick? This is a very important thing that we need to do. Yes, yes, okay, we can have all the variations of Frick, but our goal is to prevent, if name equals Frick, something. But how can we say, like, how can we stop somebody from saying, like, over here, just being like, p.name equals Frick? Like, no matter what checking we do, we gotta stop somebody from just doing this. Because what we're doing here is we're directly just setting the name. And no matter what we put in any of these methods, this will just directly change the name. Like, we can put whatever code we want in there, right? Like, but if we directly edit the name, then yeah, you're on the right track with a getName method. But not quite. Well, first things first, as you guys might remember from my botched attempt at the cartel thing, you might notice that there's like private and public things, right? So how could we go about preventing somebody from directly modifying name? Sure, what's up? We're not letting anybody be named Frick because I would need an example of how to use getters and setters to do input validation, and that's the best example I could come up with on the spot. There's otherwise no real good reason for it. So yeah, Mr. Sen Gupta or Miss Sen Gupta has an excellent idea with privating the name and then set name. So that's right. We can set the name field to be private, and notice how right away that's going to put an error right over here in p.name equals Frick. So that's kind of solved part of our problem. Nobody can now directly edit the name and change it to Frick. Great progress, fantastic innovation, but we've still got a problem. right in the constructor, I can still put Frick. And that's just terrible, because if I run the code, their name is Frick. And that's just not okay. So what else do you guys think we could do to prevent us from naming this guy Frick? Yeah, we could kill someone, but that wouldn't work because we have to know when to kill them, right? Like, we couldn't just kill everyone. That would prevent people from being called Frick, but that would not... Yeah, you're on the right track about an if statement. Yeah, and you're right on the right track about set name. But how about the constructor right here, right? Where we take a name here as input, and we set this.name equals name. So yeah, we could just say if name equals or dot equals, if we want to do a proper string comparison. Frick. And we don't want it to be equal to that, so we'll just say not. Then, alright, if we run this, perfect. We have created a solution which prevents somebody from being named Frick. However, there's now yet another problem. We've now locked it down so much that nobody can actually change the name. So yeah, Tristan's got the right idea with creating a set name method. So if we want to be able to change a name, but we want to enforce certain rules about what names are okay, such as whether or not somebody can be called Frick, we can have a public void set name, which takes a string as an input, name, and then we can if name, but you know what? I'm really lazy, and I really don't want to rewrite this code about if name equals Frick. So what I'm going to do is I'm going to say this.name equals name, okay, and then here in the constructor, all I have to do is I have to say set name, name. And now that takes care of all of the validation. So yeah, as Tristan said, we create a set name method, and we set our name to the name using that. And now, when we call set name, person called Frick, doesn't want their name to be null. I'll re-explain that in a second, about why we have to create a set name. But here we can say set name to be not Frick. And that will work, because their name is now not inappropriate. Why aren't we using import java.scanner? Because I don't really have a need to type anything in. Like, I'm okay just showing examples like this for now. We're not using import java scanner because I'm just lazy at this point. I don't want to type things in where I can just have it all saved. For the sake of this demonstration, it won't save any time to use the scanner. But yeah, so I can now, with the set method, be able to alter the existing field, and bloody webcam. Absolute nonsense. Alright, well, you'll have to excuse my webcam being bad for today. It's just turning on and off on its own. Anyways, yeah, I can make it so that nobody can set the name Frick to the person. I don't really understand the class tester and the set method. Okay, so I'll go through it once again. We're trying to enforce a rule on the private string name. And the rule we're trying to enforce is that nobody can be called Frick. So instead of letting people directly modify the name with it being a public field, or instead of letting people send in whatever name they want to the constructor, we created a method to alter the name. And this method takes in what somebody wants to be a name. It checks whether or not it's Frick. If it's not Frick, they can set the name. If it is Frick, they can't do it. And so this method basically acts as a gatekeeper that prevents people from being called Frick. And instead of being able to directly access private string name, the only thing that's going to have access to that is this set name. If that kind of makes sense. Like, the only way we can ever get to name through outside of the class is to do this with private string get name. But we also have the other problem of we have no way to get the name, so I'll just quickly do that. I forgot I didn't have a getter, so public string get name, return name. Alright, so now we can actually see that the string can only be, or the name can only be set to a string that is not equal to Frick, because we want that to be our rule, and we can get the name using get name. And here we can say in string, it actually already works, but yeah, we can get the name outside as well. Hopefully that makes sense to you guys. And the reason we have this separate class is actually no reason. We could have just put this method inside of the person class. I was going to put this here so we could have other things later on. So I could be here like public tester, whatever, or public tester. Bad convention. Anyways, yeah, I was going to do it here so we can have examples of two classes interacting with each other, but I don't know if we'll be able to get to that today. So for now, the tester class exists for no reason. Does anybody else have any kind of questions about what we did here? Hopefully it's like a little bit clear. Sorry, it's a bit improvised there. I was unaware of exactly where everybody was at with object-oriented programming. So yeah, anything unclear to you guys, I could try to explain in a bit more detail. Why do we use set name rather than get name? Off topic, but do we have naming conventions? Okay, I'll get to both. So why do we use set name rather than get name in the method person? Well, there is no person method. Let's get the terminology straight first. Person is a class. Set name and get name are methods, and name is a field. All right. So the reason that we say set name and get name is that get name is just gives something the name from outside the class. So if you are out here and you want to access name, but it's private, it's not going to work. If I'm going to say p.name, it doesn't exist. So to get the name, we use get name. It's just a convention as to why we have that. It's pretty simple. So why do we have naming conventions for private and public methods? There's no naming convention for public versus private methods. However, there are naming conventions which I'm not properly following for classes. Like this should be a capital letter and such. Kind of makes sense, hopefully. And the swear word line here, this one, the reason it's static and final is that it's static because every person is the same swear word. And the reason that it's final is that it's never going to change. No matter when you run the program or what you modify, you'll never be able to modify swear word. It's just an inherent variable that exists. So in another example, like a math program example, let's say you're making a calculator, you could say public static final int pi equals 3. Is this for my engineering friends out there? You can always set something that's just a universal constant that will never change with final. And that way it saves you a bit of memory, it's just a little bit more efficient, and that way nobody can screw up. And static means that it's constant for every person that will be created. Yeah, exactly. And final means that no matter what, you can never change it. So anytime this program is run, anywhere it's run, no matter who does what with it, they won't be able to change int pi equals 3 or swear word equals frick. That won't be able to be modified. So that should explain final. And I think that probably went through every modifier that we have access to, except for protected, which is just not very often used. Protected makes inheritors only use it, and we haven't gotten to that yet. So it's like set name makes the user of the program gives the name. Yeah, set name can make the user of the program give a name, but it can also make another class give the name. So if we have here, we've got a class called tester, right? And let's say public tester is the constructor. And in public tester, let's say every tester has an associated person. P. Now the tester can say person or P is equal to new person, and then P dot set name not frick. So you can change static, but not when it has final. That's correct. A static field can still be changed. So public tester is the constructor. Now this has an associated person. So it's not just a user of a program who gives the name. It's also other code, like other things. If we had, like, let's say a generator of random names or something, and we didn't want it to put in swear words, we could use we can call set name in the name generator, and then the name generator would be able to set the name to whatever it wants, unless it accidentally generated a swear word. So it's not just for people, the set name thing. It's also for your own code, because there are situations where your own code might try to do things that it can't do, and that's why we have those methods there. So can you change static even when it is not final? You can change static, but static would change for every instance of the class. Like that would be that would be a bad thing to change. Like if I wanted to say, let's static species, so I can do species equals new, but I can't actually change it from an object-oriented thing. I could probably be like person equals, yeah, and that it works, right? You can change it. But it's bad because now you've modified not just this object, but you've modified every single person. So if I was to change the species of human, let's say somebody came up with a new name for us, like, I don't know, human with a capital letter, something like that. That would change species, but it would change species for every human in existence, rather than just the specific one you were working with. And that's why the reference I made was not to this, but it was to the person class. Can you re-explain the set name method? Yeah, the set name method, instead of letting us access name from anywhere in the code, and instead of having the name be set using a normal set name, we added this if statement to make sure that if somebody tried to change the name, they couldn't change it to frick. Hopefully that makes a bit of sense. As for could you put set gender? Yeah, I could put set gender. Like I can make it so that everybody can only have the true gender. If they had the false gender, then they could be prevented from changing it to that. Or I could even make gender private and make it so that you can't change it. Like you can do all these kind of stuff, and that will work with any of the fields. And if you try to switch swear word, will it raise an error? Well, you can't actually switch. I don't think your IDE will let you change swear word. Like I don't think I can be like. Can I do it? Can I say person dot swear word equals? No, I can't. It's not going to work. It's going to highlight it red. It's not going to be combined. It says the final field cannot be assigned. So it's not even that you'd get an error. It'll just never let you run the code. Your IDE will give you an error before Java ever sees it. It won't let it compile. It'll be a compile time error. That's what I was trying to say ineloquently. So yes. Now hopefully that should give you guys an understanding of the very basics of this stuff. Sorry I tried to go into the cartel thing earlier, but now for the last little bit, I'll maybe try to explain how this ties into that. So you can notice that in the cartel, I had inside a package is irrelevant, and I don't quite understand the point in static final if you have set name. Alright, so static final and name are two different things. I'll explain that too. What class were we working with here again? Person? Yeah, we're working with person. So the reason that we have static final is that we're setting a swear word, and the only reason I put the swear word as static final is just for the sake of having clean code. Like, we know that the swear word will never change no matter when it's run. We know that nobody will change the swear word at runtime, so we know that we can afford to make it static final. And usually, if we can afford to make a field static final, we may as well make it static final because it's better. Like it's just, if it can be, it should be. And an IDE like IntelliJ, if something can be final, will actually highlight it yellow and tell you that you should make it final, if it's possible. Like it'll analyze, see if it's possible, and it'll tell you to. Eclipse won't tell you to, but you'll just kind of know that if you never modify something in runtime, you can make it final. Is this all inside of a package? Yes, this is all inside of a package. It's inside of the Sicilian package, but that actually doesn't matter right now. That we can get to later when we're working with all these other things. So yeah, for now, not a big deal. As for the cartel analogy thing, you can see that here, what I was trying to show before, but maybe didn't give you guys enough of an understanding of before I tried to, was that the fields here used to not be private. The fields here used to be accessible from outside of the class, and that enabled Attack the Cartel to just destroy the whole thing because it allowed people to modify these things from outside. And the reason that I had this police thing here was I was going to show you guys the fact that the cell method is actually a getter and a setter method. If I go into cartel.java, here the cell product method is essentially just a getter or a setter. It's setting the merchandise to be less than it used to be. And it's also doing a bunch of other stuff. It's a bit more complicated, so I'll explain it once I give you guys a better understanding of what's going on. But essentially, it's checking that the buyer is legit before it's selling that. And that's a method of input validation that you could also go through. Like when you create a getter or a setter method, you don't necessarily only have to have an input be what you're inputting. In something like a web API, let's say you're making like a website or a web service, you might actually have reason to have other arguments. So you might say you have a name that you're setting here, and you might also put string password. And you might say like, you know, and password dot equals, and then you can have like whatever password validation that you're using, right? So you don't just have to have setter methods have only one argument. Yes, a setter technically should only have the argument of the thing you're setting for now, but if you wanted to be really advanced and you wanted to like protect something and make sure that whatever's accessing it really has the proper access, you can also have other arguments that help your input validation. And that's hopefully another idea that you guys probably won't need having other arguments in here. That's a bit advanced, like a bit over the scope of Comp 250, but it's also possible to do more advanced input validation through getters and setters. And the whole point of that was just to explain that we have a goal in programming generally, which is to increase what's called encapsulation. And the point of increasing encapsulation is we want to be able to modify as little as possible about a class from outside of that class. We don't want to be able to access things directly. We want to access things in a way that lets the programmer define rules. So instead of being able to access the name field directly and just mess with it, we want to have a rule for the name field, for example, not to set it as a swear word, or just other rules. Like if you say, want to put a limit on how often people change their names. If you want to not be able to have people, if you're making like a banking app, you don't want people to be able to change the amount of money they have directly. You want to be able to make people change the amount of money they have only through certain other procedures. For that reason, we have private, we have getters, and we have setters, so that we control access to our different variables, to our different methods, and we have programs which are harder to break. And it's not just being broken by attackers, it's also a matter of being broken by improper use. But yeah, I think that's about that for the topic of getters, setters, private, public. Hopefully that boosted you guys' understanding. And my home phone is ringing, which is strange because I don't even pay for it, but whatever. We can ignore the ringing sound. If you guys have any other questions, I'll be happy to answer them. And yeah, we can leave it at that for now. On the Thursday tutorial, I think I'll be going into more of this Sicilian class with the mafia analogy. Maybe I'll do a better, like a simpler version for that tutorial. But for now, hopefully you guys can understand the concept for this kind of improvised impromptu version. And again, if you have any questions, please do let me know and I can happily answer them. And I think that stopped ringing now, so thank God. When will the recording be posted? It'll be posted right after this tutorial is over, once I get the video uploaded. And yeah, all right. Hopefully you guys have a better understanding of all this stuff now. If nobody has any more questions, I'll be wrapping it up shortly. And if you want to see the Thursday version will be similar, but it will actually have a much simpler cartel thing. I think I'll revise the code in that to consolidate it, make it a bit easier to understand, and try to go through the original analogy, make it work a bit better. But for now, yeah, we'll leave it at that. Enjoy the rest of your Monday. Hopefully, you'll have a fantastic time partying it up. I bid thee a farewell.